So the reflection or the consideration that we want to make here is, if we look at the cash flows in our portfolio of insurance contracts year after year, can we then say something about the profit or the loss that we're making in a particular year? And what we're going to do for that is we're going to compare the assumptions that we made in our policy value basis in terms of interest rate, in terms of expenses, in terms of mortality rates. We're going to compare that to what the scenarios that actually happened throughout a particular year of time. Because what we can say is that if all the cash flows between t and t+1 would unfold as assumed, as specified in our policy value basis, then we're operating in a break-even situation in the sense that the assets, the capital that we build up at t+1 is exactly equal then to what we expect to need in terms of liabilities at t+1. And that's what our recursive relation was saying. On the left-hand side, that was the assets available at t+1. The right-hand side would be the expected liabilities at t+1. So if everything happens as assumed, we'll have a break-even situation there. But of course, if some of the assumptions that we make in the policy value basis, if those are different from the reality, then we'll either realize a profit or a loss. And that should be monitored. For a portfolio of insurance contracts. So here are some examples of possible profit scenarios. You make expenses, actual expenses, which are less than what you assumed. So you're making some profit in terms of the expenses. In case you're dealing with an insurance product, if the actual mortality is less than the mortality assumed, you will have to pay out less euros in terms of death benefits, right? So you make a profit there as well. And if you look at some possible loss scenarios, if the actual interest earned is less than the assumed interest, then you're making a loss because your capital does not grow as fast as you assumed. Or if your actual mortality is less than the mortality assumed, then you're making a loss in case of a life annuity setting, because then you have to pay more life annuity benefits than you actually assumed, right? So there are different scenarios which are possible. And essentially, we're going to focus on profit or loss resulting from interest rates, resulting from expenses, and resulting from mortality assumptions, because these are the assumptions that we're making in our policy valuation basis. So we're going to tackle this question with an example, so with a concrete exercise. And we're going to look at a setting where we issued endowment insurance policies to women age 60, right? We made certain assumptions in this, so this exercise follows up on exercise or example 7.3. So we made there certain assumptions. I'm just stating there in the example 7.3, we assumed a 5% interest rate, expenses of 10% of the first premium, 5% of the next 200 euro expense on when we have to pay the sum insured, right? And what we're now going to do is, those were the assumptions in our policy value basis. And now 5 years after these contracts were issued, we have a total of, say, 100 of these policies still in force. And in the next year, we see that the real expenses are 6% of each premium paid, instead of the assumed 5%. And we realize that the interest earned was 6.5% instead of the assumed 5% interest rate. We realized that, or we observed that one policyholder died, so we have to compare that with the mortality assumption that we made. And the expenses on the payment of the sum insured for the policyholder who died were 250 in reality compared to the 200 euro that we assumed, right? So the idea is, can we say something about the profit or the loss on this group of contracts for this particular year? And once again, this has to do with comparing the assumptions that you made in terms of interest rate, expenses, mortality assumptions. you want to compare your assumptions against the actual realizations. Yeah. So let's focus first on this particular example and then derive a more general setting. So we look here at, we put ourselves at time point 5. At that point, we have 100 policies who are still in force. So according to the policy valuation assumptions, for each of them, we will have a capital at time 5 or an asset at time 5 worth 5V, right? That's the policy value at time 5. We've got 100 active policies, so that's the capital that we will hold at time 5 in terms of our policy valuation basis. So let's look now at the cash flow stream between time 5 and time 6. Well, first of all, at time 5, we're going to receive premiums. And we're going to receive premiums for each of those 100 active policies. So that's 100 times P that we can add to the assets that we already have, right? But we will also have to cover expenses related to the premiums. And in the reality, in the information that was given on the previous sheet, we see that in reality, these expenses turn out to be 6% of the premium, right? So 6% of the premium, that was the actual expense that we incurred between time 5 and time 6. So that gives us, in reality, the following assets, the following amount that we hold at time 5. Okay, so here I do 100 times P and I subtract 100 times 6% of P, taking into account these expenses. Now this amount of capital at time 5, it will grow to an amount at time 6, and it will grow according to the actual interest rate that we are realizing. And that was 6.5%, as was mentioned on the previous sheet, right? So the numbers that you see over here, the 0.94 and the 1.065, these take into account the actual realizations in terms of premium related expenses on the one hand and in terms of interest rate on the other hand. Okay, so what we're now going to do is we're going to look at the debt benefit, so the debt claim plus the related expenses at the end of year 6. So we know in the scenario that actually happened over time, one of our policyholders dies. So that means we have to pay the 100,000 once for one policyholder at time 6. And we also have to pay for him or for her this related expense of 250 euros. So we need to pay 100,250 euros at time 6. And again, the 250, that's the actual expense that we encountered for this one policyholder who died, right? That's what we have to pay in terms of the debt benefits. Now, if one policyholder dies, it means that 99 policyholders are still in force at time 6. So for them, we need to hold the capital 99 multiplied with the policy value at time 6. And this policy value, that's the value that we calculate according to our policy value assumptions. So how can we now reflect upon the profit or the loss that we made throughout the 6th year of our contract, so between time 5 and time 6? So what we're then going to do is we're going to look at the capital that we build up at time 6, and we're going to subtract what we need in terms of the debt claims and expenses that were paid, and in terms of the policy values, the amount of capital that we need to hold at time 6. So the profit that we're making in this particular year is obtained by comparing and by making the difference between the capital that we build up from time 5 to time 6, taking into account the actual expenses, taking into account the actual interest rate, and subtracting from that the capital that we need to settle our debt benefits and expenses on the one hand, and to make sure that we hold enough capital for the surviving policies on the other hand. And so here we also take into account the actual realizations and the actual amount of debt benefits that we had to pay, the actual expenses, and the actual number of survivors. So in this particular setting, it turns out if you use the values for the policy value at time 5 and the policy value at time 6 as calculated according to your policy valuation assumptions, it turns out that in this particular case, you get a profit of 18,919 euros on this group of 100 contracts. And where does this profit come from? What is the main source, or what is the big source of the profit here? If you look back at our original assumptions compared to our actual realizations, here the profit is coming from. Anyone? Anyone in the chat? Or anyone who wants to go live? So here the profit was coming from the fact that we have a, let me see, very good, Winston, indeed, the interest rate. We assumed in the policy valuation basis an interest rate of 5%, and we realized in reality an interest rate of 6.5%. Yeah? So we see that here the profit is coming from a gain on interest rates, whereas in terms of the expenses, we did worse in reality compared to what we initially assumed. Yeah? So there we made a loss. Okay, so this is just one example of how you can take a look at these things. What I want to do now, and this is not written in the book, but I want to give you a more general view on this. So I want to use formalistic approach to write down in a formula how I can allocate this profit and loss throughout a particular year of my contract, how I can allocate this to different sources, to interest rates, to mortality rates, and to expenses. Yeah. So let's see how we can do this. And I think I'm going to do that on the iPad just to make sure that we can follow this a bit better. All right, so let's give that a try. So my starting point in this derivation that I want to make, my starting point is the recursive relation as we derived it. The recursive relation that gives me t plus 1 v as a function of tv, right? So that's what we did in the first hour of today. So there we said, well, if you look back at this recursion, you have to work with something like this. So that's t plus 1 v plus q x plus t, and then st plus 1 minus, sorry, plus expense related minus t plus 1 v. So we can rewrite that and retrieve an expression for the policy value at time t plus 1. That would be tv plus pt minus the related expense multiplied with 1 plus the interest rate realized between t and t plus 1 minus q x plus t, and then this guy. And now the only thing I need to do in order to reflect upon these profits and losses is I want to write down an expression for the actual reserve, and I want to write down an expression for the expected reserve. And if I make the difference between these two, then I'll be able to say something about the profit or the loss in a particular year of the contract. So if we look at the actual interest rate, the actual reserve or policy value, we're going to denote that with t plus 1 VA, where the A is for actual. So what we're going to do there is, if you have a group of contracts, say NT contracts in force at time t, then the actual reserve, the actual amount that you're going to hold is NT multiplied with TV plus NT times PT minus NT times the actual expense, which I'm going to denote with a prime notation. So it's the actual expense multiplied with the actual inflation or the actual interest rate minus then ST plus 1 plus the actual expense minus T plus 1 V times dt prime. And what is this dt prime? Well, that is my Q here, the actual Q, multiplied with the number of policies that I have in force. So it's the actual number of debts that I will observe on my group of contracts between, so where the dt prime is my Qx plus T prime, the actual mortality rate multiplied with the number of contracts in force at time t. Yeah. So this is the actual situation. This is what I will actually hold in terms of capital. Now I want to compare this with the expected capital. The expected reserve or the expected capital at time t plus 1. And of course, for this expected capital, everything will be as according to the policy valuation basis. So I'm going to use the expenses, I'm going to use the interest rate as I actually assumed it in my policy valuation basis. So there are no prime notations over here. I get here NT multiplied with the QX plus T, right? So these are the very important ingredients. I've got the actual reserve, the actual assets that I'm building up from T to T plus 1. And I've got, on the other hand, the expected assets, yeah, where everything happens as I assumed in my policy valuation basis. And now, of course, where is the profit or the loss coming from? Well, I simply obtain my profit or my loss between time t and t plus 1 by taking the difference between what I actually realize and what I expect to happen. Okay, so that's what I can, that's what I will obtain over here. So let me check. So if I would write that down, yeah. So what we can do, if we then look at the profit or loss between time t and t plus 1. So what we're then going to do, what we're going to compare is the actual capital that we're holding versus the expected capital. And if that amount is positive, we're making a profit. If that amount is negative, we're making a loss. So the only thing you need to do is you take the formulas from the previous sheet, you plug them in over here, and it will turn out that if you massage these expressions a little bit, that you can write them as follows. So I'm not doing the full derivation, but I want to show you the final step, because there you will clearly see where the profit or the loss is coming from which sources the profit and the loss is coming from. So the only thing I need to do here is take the difference of the two expressions that I just build up, put things together, massage this expression, and I'll get something like this. Yeah. So that is what the difference can be rewritten into. And why is that helpful? Because now you recognize three building blocks. So there is this block, which deals with interest gain or loss. Yeah, because you see the driving force here is the difference between I prime, the actual interest rate that we're realizing, and the interest rate that we assumed. And if I prime is higher than the interest rate that we assumed, we're making a a positive number here, we're going to make a profit. And then the second component in this expression is dealing with my expenses. So this guy is dealing with the part of the profit and the loss that is driven by the difference in the expenses. So here you see that if the actual expenses, without a prime, if they are larger than, if here you see that the actual expenses with a prime, if they are smaller than the expenses that you assumed, and both for the premium related expenses as well as for the expenses related to paying out the death benefit, then you're making a profit. Yeah? So this is the part of the loss that deals with the expense gain or loss. And then for the final part, what I see here is that this component is driven by the mortality gain or loss. So here what we are comparing is the assumed number of deaths according to our assumptions versus the actual realized number of deaths. Okay, so that's a very general way of looking at this annual profit by source. This formula is not given in the book, but I think it's a nice generalization of the example from the book that we covered together. So we can look at the total profit or loss, and then we can attribute this profit or loss to one of the three sources that we discuss here. So interest rate, expenses, or mortality rates.